Okay, so today we're going to look at arithmetic sequences and partial sums. So an arithmetic sequence we've talked about in the last section is also a linear function. So it's going to have a common difference. So when we look at those consecutive terms, there's going to be a common difference between the first term and the second term, the third term and the fourth term, so on and so forth. And that is also called the slope of a linear function. But when we look at a sequence, we call it the common difference. So if we're going to find the nth term of the arithmetic sequence, we always want to start with the first term, and then we could add n minus 1 times that difference. So if we're looking for the formula for the nth term of an arithmetic sequence that has a common difference of 11, and the first term is 4, well, we could write it as 4 plus n minus 1 times 11. If you simplify it, it's going to look a lot like a linear equation. So we know that that's going to be 11n, and if we add or subtract 11 from 4, we would get -7. So that would be the formula for the nth term. Now if we look at the next one, when we're looking for the common difference, when we're saying what's the difference between 5/4 and 1, so what do we have to add? Well, we have to add 1/4. And that makes sense because if you add 1/4 to 5/4, you get 6/4, which is 3/2, and then you get 7/4. So when we write the formula, we know that that's going to be a sub n, and we're going to start with 1 plus n minus 1 times 1/4. And to simplify that, we know that that's going to be 1/4 n plus 3/4. Now for the next example, we're given the fifth term, which is 19, and the 16th term, which is 24.5, and we have to find the first 5 terms. So first let's consider the difference, and we can find it just like we usually do for slope. 24.5 is that 16th term minus 19 over n equals 16 minus n equals 5. So that's going to be 5.5 over 11, so the difference is 0.5. So if we start with 19 and we need the first 4 terms, well, we can kind of think of this as well as 19 minus 0.5 times 4, right? That would equal 17. So that must mean that we're going to start with 17, or you can work backwards as well, if you like, because there's just 4 terms here. So 17.5, and the first term is 17. To find the 10th term of an arithmetic sequence, well, we're going to have to find the formula. So if we have 8 to 20, well, then you know that difference is 12. And you could easily write that formula as 8 plus n minus 1 times 12. And if we want to find the 10th term, you just have to plug in 10. So this will be 10, so we'll have 8 plus 9 times 12. And that's just going to be equal to 116. Now let's look at the sum of finite arithmetic sequences. And let me share you a story about young Gauss. So as the story goes, when he was a young kid in the classroom, his teacher asked him and his classmates to add the first 100 integers, probably hoping that this would keep them busy for a little while. And Gauss was able to figure this out really quickly, probably to the surprise of the teacher and his classmates. So he didn't add up all those numbers in his head, he actually figured out a pattern, and in a way you could say he folded the series of numbers. So looking at the numbers 1 to 100, if you add 1 and 100, you get 101. When you add 2 and 99, you get 101, and so far and so forth. So 3 and 98, 4 and 97, and in the 100 numbers, we have 50 of those pairs. So 50 times 101 gives us 5,050. And that's what we're going to use to find the sum of finite arithmetic sequences. We need to know the first number, we need to know the last number, and we're really going to find how many pairs, or divide the n number of terms by 2. So for practice, let's find the sum of these numbers. So you could tell we have 7 numbers in that sequence. we'll have S sub 7. So 7 divided by 2, our first number is 56. Our last number is 20. So we'll have 3.5 times 76, and that equals 266. So to find the sum of 1 to 40, well, we're going to have 20 pairs, because 40 divided by 2 would give us 20. And so 20 times 41 would just be 820. And then 1 to 57, we're going to divide 57 by 2. Won't have an even number of pairs. And we're going to multiply that by 58. So that's 1,653. Now let's look at example 7, where we want to find the 50th partial sum. So we're given that the arithmetic sequence is -6, -2, 2, and 6. And you could tell that we're adding 4 each time for the next consecutive number. So we can write this formula as a sub n -6 plus n minus 1 times 4. And thinking of a linear function, you could probably write it as 4n minus 10. To find that 50th term, we just have to plug in 50. So 200 minus 10 equals 190. So let's find the sum of those 50 terms. So we're going to have 25 pairs, right? 50 divided by 2. Multiply that with the sum of -6, the first term, and the last term. So it's really just be 25 times 184, and that equals 4,600. All right, so for example 8, we're going to find the 20th partial sum. So we're given the pattern of numbers here, and you can see that the difference, it's going down by 7. So if the first term is 200, well, the number right before it, right, the y-intercept must have been 207. So we can write this as a sub n equals 207 minus 7n. And so when we plug in 20, we want to find the 20th term. 207 minus 7 times 20. So 207 minus 140 would be 67. So let's find the sum of those 20 terms. So we're going to have 10 pairs, and we just add 267. So 10 times 267, that's just going to equal 2,670. For this last example, we'll consider a job offer that pays a starting salary of $32,500. And every year, you'll get an annual raise of $2,500. And you want to figure out the total compensation for 6 years of employment. So that's a summation. And we also have an arithmetic sequence. So our first number is 32,500. And our difference is 2,500. And think of a line, right? This is a linear. We know that that starting salary, or that a sub 0, would be 30,000. So we could write this as 30,000 plus 2,500 n. And so if we want to figure out how much we'll earn after 6 years, all we have to do is plug in 6 for n, and that's going to be 45,000. And so if we want to figure out the total earnings after 6 years, well, that's going to be 3 pairs. So it's 6 divided by 2, and then we're adding 32,500 and 45,000. So 3 times 77,500 equals 232,500 for all 6 years. All right, well, I hope this lesson was helpful, and please feel free to ask questions when we see each other in class.